Welcome to Brainworks Trigonometry session. Have you ever wondered how you're going to be able to answer this type of question in trigonometry? Mind you, paper 2 mathematics carries quite a lot of marks, and I believe if you master the concepts and if you master each specific topic that you want to answer in paper 2, you're going to be 100% ready for your ECZ or GCE examinations. So I'm here to help you answer this trigonometry question. And trigonometry is basically split into 3 categories. So you're going to see trigonometry of right-angled triangles. You're going to see trigonometry of non-right-angled triangles. And you're going to see something like this, which is called trigonometric equations. So at the end of this lesson, you have to be able to competently gain all these marks in trigonometry without fail. And this is how you pass an examination. You have to tell yourself, I'm going to master this topic properly, and whatever question comes in the exam, I'll be able to answer it without any particular problems. So what is trigonometry? So trigonometry is a branch of mathematics which has quite a lot of similarities with algebra. It gets onto algebra, it gets onto calculus, but the main core of trigonometry is the relationship between angles and their sides in relation to triangles. That's it. You have to first learn trigonometry of right-angled triangles, the SOHCAHTOA. Then you also have to continue with that and learn trigonometry of non-right-angled triangles, where you have to know your cosine rule, where you have to know your sine rule. Then you have to go a little bit beyond trigonometric ratios to define those trigonometric ratios to suit angles that go beyond 90 degrees throughout all those quadrants, your first quadrant, second quadrant, third quadrant, as well as your fourth quadrant. If you have all this knowledge, there is no way you're going to fail any question under trigonometry. So let's begin with trigonometry of right-angled triangles. So let's say we have a right-angled triangle described by ABC. If this right-angled triangle will always have a 90 degree here. That's the basis of a right-angled triangle. And because the definition of trigonometry, we want to define ratios of the angles in relation to the sides. Meaning, if we have a given right-angled triangle, we can construct these basic 3 trigonometric ratios. Of course, these trigonometric ratios come from principles of the unit circle combined with Pythagoras theorem. But for O-level mathematics, we don't really consider questions regarding the unit circle. You just have to know how to describe your trigonometric ratios in reference to given sides. So we proceed. So we have this triangle ABC, and we can call this angle here angle theta. So we can describe trigonometric ratios based off this angle theta in relation to each side. So if we follow this edge of this 90 degree angle to the other side, we're going to call this the hypotenuse. If we follow this angle that we've called theta to the other side, it will be the opposite side. Then the remainder side that is adjacent to this angle, just next to this angle, would be called our adjacent side. So we can describe trigonometric ratios of this angle theta here in relation to all of these sides. How do we do that? We will say, so, TOA, and our given angle here is theta. Notice that this angle, today we've called it theta. Next time it can be angle beta, or next time it can be angle BAC. Don't just say this is angle theta and say sine theta is opposite over hypotenuse. No, it has to be in reference to a given angle. And this time the angle that has been given is angle theta. So we're going to define our trigonometric ratios based off this given angle right there. So the first one will be sine theta will be our opposite over hypotenuse. Our cosine theta will be adjacent over hypotenuse. And our tan theta will be our opposite over adjacent, like that. So we've been able to describe three trigonometric ratios based on the angle and the given sides. We had the hypotenuse, we had the opposite side, and of course we had the adjacent side. Let's now take theory into practice and look at a given question. So we have this question here, and this question is telling us to find angle DAC. So when it comes to angle DAC, we first locate the angle. And by the way, when you are solving trigonometry, make sure you reset your calculator in default mode. It's going to go back to a measure of degree. Students usually lose marks because they don't notice that their calculators are set to radian mode. So as a precaution, just there's a reset button behind most calculators. Just press that reset button. It's going to go back to default mode, and the measure of the degrees will be, the measure of the angle will be in degrees and not radian. You might do the correct thing, solve, show your working, and then when you punch your trigonometric ratio, your answer will be in radian and not in degrees. So it will make things a bit difficult. So let's first locate this angle. So we've been told to find angle DAC. So DAC, this is the angle DAC there that we want to find. This is angle DAC. Let's collect data of the things that we have here. So let's find the hypotenuse. So the hypotenuse is right there. 12 meters is the hypotenuse. And this is right next to this angle DAC. So this is going to be the adjacent side. So let's collect data. So the data that we have is the given angle DAC. So whatever trigonometric ratio that we're going to use, it will be in relation to this angle DAC. We have got the hypotenuse, which is 12 meters, and the adjacent side, which is 8.4 meters. So we now have to see which type of trigonometric ratio can we use in relation to this angle. So we'll say so, ka, toa, and of course you can easily see that the trigonometric ratio which has the adjacent side and the hypotenuse side will be cosine. So we're going to say cosine the angle, which is DAC. We'll say cosine DAC is equivalent to the adjacent over the hypotenuse. So our next step here, step 2, we have to now substitute. So what do we have here? We'll say cosine, the angle that we want to find, DAC, is equivalent to Our adjacent is 8.4, and our hypotenuse is 12. So we'll say cosine DAC. We get our calculator and say 8.4 divided by 12 will give us 0.7. So once we reach here, we want to make DAC the subject of the formula. So to make DAC the subject of the formula, we have to use the inverse of cos. That's how we make DAC the subject of the formula. So we'll say DAC is the inverse of cosine 0.7. So to get the inverse of cosine, if you're using a Casio, you're going to say fifth cosine. If you're using a sharp calculator, it would be second function cosine 0.7. And you're going to get your angle DAC as 45.6 degrees. You can even round it off to the nearest angle and say it's 46 degrees, but one decimal place is sufficient. So this is how you handle trigonometry of right-angled triangles. So if you enjoyed this first introductory class, please make sure to book a class with me. So at the end of the day, with the BrainWorks Mathematics lesson plan, this is an exclusively one-on-one lesson. You're going to learn with me, BrainWorks Education. You're going to get a one-on-one online class on Zoom, recorded, covering the entire trigonometry. So this will be approximately a 2-hour intensive class where we're going to look at trigonometry of right-angled triangles, trigonometry of non-right-angled triangles, and we're going to look at area of a triangle, finding the shortest distance, and we're going to end with trigonometric equations, as well as simplification, algebraic fractions, because this topic usually comes together with the last question is usually a an algebraic fraction. So we're going to do all those concepts. And at the end of the day, you're going to have access to your own personalized recorded session, because you have to take charge of your own education. You're not going to rely on a group setting. Make sure you understand the concepts first by yourself, and then you use something called the Feynman technique. Feynman technique means if you can't teach a concept to others, it means you yourself haven't fully understood that concept. So once you have this session with me, you understand your trigonometry, go out there and solve past paper questions with your colleagues. So book a session with me. You can contact me on this number. Please send me a WhatsApp message, and the price will be 120 kwacha for this trigonometry session. Happy learning. Hope to see you soon.